Class example 3.6.3. We've got two graphs here, and we just want to figure out which graph has a rate of change of -5 and a vertical intercept of 100. Justify your answer. Another way to say vertical intercept would be the y-intercept. I abbreviate it. Y-intercept is when x is equal to 0 and y would equal to 100. That's the easiest way to look at it. So let's start there. In question A, or graph A, it looks like I do have a y-intercept of 100, but I also have a y-intercept of 100 in question B, so that works for both. So now we've got to talk about this rate of change, and there's a couple of things that we can do. First of all, we know that rate of change means that as we are decreasing our x values, as we are having a consistent change in our x values, we're looking for a consistent change in our y values. So let's just quickly look at time versus distance and some nice points for both of these, and then we'll talk about what's going on here. So it looks like I've got 0, 5, 10, 15, 20. So 0, 5, 10, 15, and 20. That is true 0, 5, 10, 15, 20 for both. 0, 5, 10, 15, and 20. And let's just see what happens. We said at 0, we had a y value or a distance of 100. That makes sense because that's what we said was our y-intercept, right? 0 and 100. I don't really know what is happening here. I think it might be 50, but let's just go here and say that, or sorry, not 50, it's 75. This looks like it's definitely going to be when the time is equaling to 10 units. This distance is going to equal to 50 units. And I can see, I'm going to jump down to the 20 because it's that nice dot here. And I can see that when time is equaling to 20 units, my distance is equaling to 0. So I also know that this is a straight line. And so halfway in between these 2 points, is going to be halfway in between the y-axis as well as the x values. So I'm going to go to 75 and 25 here because that'll be halfway in between the actual distance on our scale over the x-axis. Okay, so this is linear, it's consistent, that's good so far. Over here, we've got, it looks like we're going up by the same scale as well. So we're going to say that each halfway is 25 points. So when distance is equaling, time is equaling to 0, distance was equaling to 100. Now it looks like it's increasing to 125. Then it's going to 150, maybe then 175, and then we're up to 200. So this is increasing. This is decreasing. So hopefully we can recognize that that -5 is actually the decreasing value in the first place. And we could have just looked at the graphs themselves, but you know me, I like to make sure that we're consistent here. So I can see here that for every 5 units I am dropping 25 units for the distance. So every time I drop 5 units, I'm dropping 25. So let's just talk about if I have a drop of 25 units for every 5 units I go along the x-axis there for the time, I could actually simplify this, right? If I know that 25 divided by 5 is 5, that's great. I also have a negative divided by a positive, so I can actually see mathematically that this is also a decreasing rate of 5 units in the distance for every 1 unit in time. I just wanted to do this one as well. So I am increasing by 5. So for every 5 units of an increase, I am actually increasing it by 25 units. So it is a positive 25 for every 5, which means this graph for B would be a positive 5 rate of change, not a negative 5. So that is what we're looking for.